Hello, welcome to Chapter 5. Chapter 5 is all about polynomials, and in this first section we're going to talk about all of the different operations we can do with polynomials. We have two main objectives. One, to multiply, divide, and simplify monomials and expressions that involve power. So this is basically going to be a review of exponent rules that you should know from Algebra 1 and Geometry. And our second objective is to add, subtract, and multiply polynomials, which is also a review from Algebra 1 and Geometry. So the new vocabulary today that you should look for is simplifying, although that's not really new, and degree of a polynomial. Okay, here is the chart with all of the properties of exponents, where x and y are real numbers and a and b are integers. So let's just do a quick run through some of these. When I multiply two expressions that have the same base, so notice both of these have a base of x, the shortcut is to take the exponents a and b and add them together. So for example, 3 squared times 3 to the 4th. They both have the base of 3. 2 plus 4 is 6, so that's 3 to the 6th. Why? Because 3 squared means 3 times 3, and 3 to the 4th means 3 times 3 times 3 times 3. When I write out what that actually means, how many times am I actually multiplying the number 3 together? 6 times, right? So you can always, if you get confused or you get stuck, you can always write things out the long way, or at least most of the time you can, and figure it out if you forget the specific rule. These properties are basically just shortcuts to helping you do exponents faster. Quotient of powers. If I'm dividing two expressions that have the same base, I do the exponent in the numerator minus the exponent in the denominator. So 9 to the 5th divided by 9 squared is 9 to the 5 minus 2, or 9 cubed. B to the 6th over b to the 4th is b squared. Again, why? Because b to the 6th means this, and b to the 4th means this. B divided by b is 1. So I can cross out all of the pairs of b's that divide out to 1, and what I'm left with in my numerator is b squared. Negative exponents. This one is sometimes a hard one to remember. Negative exponents. If my exponent is negative, not my regular numbers, but my exponent. A negative exponent means reciprocal. A negative exponent means take the reciprocal. So x to the negative a is 1 over x to the a. If I have my negative exponent in the denominator, I still do the reciprocal and it moves to the top. So 1 over x to the negative a is just x to the a. So you can look here at these examples. 3 to the negative 5th is 1 over 3 to the 5th. 1 over b to the negative 7th is b to the 7th. Okay? Power of a power. If I have an exponent, so here I have x to the a, raised to another exponent b, I multiply my exponents together. Let's look at an example. D squared to the 4th is d to the 8th. Why? Because d squared to the 4th means I'm multiplying d squared 4 times. So that really means d squared times d squared times d squared times d squared, which you can see equals d to the 8th. Power of a product. So what happens in power of a product is that inside of my parentheses I have different bases like x and y, or maybe it might be 3x or 2z, raised to the same exponent. So basically what happens, since that means that I'm taking both of the bases inside my parentheses to the same exponent, I can take the exponent to both bases. Why does that work? If we look here at ab to the 3rd, notice the a and the b are in parentheses, so that exponent of 3 goes to the a and the b. What does that mean? It means ab times itself 3 times. A times a is a cubed, and b times b is b cubed. That's why the rule works. Power of a quotient, same idea. If I have a quotient or a fraction with different bases raised to the same power, that power goes to the numerator and to the denominator. So here they're showing you an example with a positive exponent. So like x over y, notice the parentheses, all squared, is x squared over y squared. If the exponent outside of my fraction is negative, remember negative exponents mean reciprocals. So I just flip my fraction. It becomes y over x to the positive a. So here I have a over b to the negative 5. So what I do is I say, okay, that's b over a to the positive 5, and then that's b to the 5th over a to the 5th. And remember, anything to the 0 power is equal to the number 1. All right, and a monomial, which is what we're going to be working with in the first part of this section, a monomial is a number variable expression that's a product of variables with non-negative integer exponents. So thinking back, remember that monomials cannot have variables in the denominator. They can't have variables under a square root or with negative exponents. So when we're simplifying, we have to make sure we simplify all the way. To make sure something is completely simplified, I make sure I simplify all of the powers of powers. I make sure I've multiplied all of my bases together so that each base only appears once. I make sure I've reduced all fractions, and I've gotten rid of all negative exponents. All right, so let's look at this expression. A to the negative 3rd times a squared b to the 4th times c to the negative 1. So what we're going to do is take our original expression, and we're going to get rid of our negative exponents. So a to the negative 3rd is 1 over a cubed. A squared b to the 4th stays the same. C to the negative 1 is 1 over c to the positive 1. And then, if I think about what these exponents actually mean, if I write them out, 1 over a cubed is 1 over a times a times a. So all they've done here is write out what those actually mean. You'll probably get to a point where you won't really need to do this, but you always can if you get stuck. And so basically I start dividing out. So remember, all of this is like over 1. So this is in the numerator. A divided by a is 1. A divided by a is 1. There's no other common factors. So what am I left with in the numerator? B to the 4th over a times c. That would be my final answer. All right, part B, I have n squared over n to the 10th. So what we're going to do here, we could write it out, but we're going to use our property for the quotient of powers. So I'll do the exponent in the numerator minus the exponent in the denominator because my bases are the same. These are both n. So I have n to the 2 minus 10, which gives me n to the negative 8. If I simplify that negative exponent, that's 1 over n to the 8th. That would be my final answer. Remember, you can always check by writing things out. So if I had wanted to do this a different way, I would have written it out like this. N squared is n times n to the 10th is n times itself 10 times. And then notice when I divide out the common factors, I'm left in the numerator with 1. There's always a 1 multiplied by everything. Over, I have n times itself 8 times in the denominator. All right, part C. We're going to simplify 3a cubed over b to the 4th, that quantity squared. Okay, so first, notice we have everything squared. So since this is a quotient, inside of my parentheses, I can square the numerator, so 3a cubed quantity squared, and I can square the denominator. Since I have inside these parentheses a base of 3 and a base of a, I have to square both of those. So I have 3 squared, and I have a cubed squared. I still have b to the 4th squared in my denominator. And then I simplify. So going back here just to look, 3 squared is 9, right? 3 squared is 9. A cubed squared is a to the 6th, and b to the 4th squared is b to the 8th. So that gives me my final answer. All right, here are some for you guys to try. The answer to this first one is c, y squared z squared over x to the 5th. And here is the work if you want to see how to do it. I just multiplied straight across first, so x to the negative 2 times x to the negative 3. Adding those exponents is x to the negative 5th. Y to the negative 3 times y to the 5th. Add those exponents, I get y squared, and then I just have z squared, and then I simplified my negative exponent. Try this one. The answer here is a, h to the 8th. The reason for that is that h to the negative 2nd, remember, if I have a negative exponent in the denominator, I take the reciprocal, so it moves to the numerator, and the exponent becomes positive, and then I use my properties of exponents to write that as h to the 8th. And try this one. Okay, the answer here is c, 4r squared s to the 6th, and there's the work for how we do that one. All right, moving on, we're going to talk about polynomials instead of just monomials. When I'm talking about a polynomial, I'm talking about a bunch of monomials being added and subtracted together. And when we talk about the degree of a polynomial, we're talking about the degree of the monomial with the biggest degree. So if you don't remember what the degree of a polynomial is, the degree of a monomial, is the sum of the exponents in that term. So we'll look at that in just a second. Remember that polynomials, like I said, are a bunch of terms or monomials added and subtracted together. So this would be an example of a trinomial, a polynomial with 3 terms. 1, 2, 3. And polynomial comes from the word poly, which means many. So polynomial just means many terms. Remember that polynomials cannot have variables in the denominator, variables under a radical, or variables with negative exponents. Okay, so the degree of a polynomial, again, here we're going to look at this example. C to the 4th minus 4 times the square root of c plus 18. Is it a polynomial or not? If it is a polynomial, then we would say the degree. In this case, it is not a polynomial because here I have a variable under a square root. That's like saying c to the 1/2. Since that exponent is not an integer, or another way to think of it is since I have a variable under a root, it is not a polynomial. Here I have negative 16p to the 5th, 3/4 plus 3/4 p squared q to the 7th. This is a polynomial because it meets all of the requirements. The degree of this term is 5 because that's the exponent there. The degree of this term is 9. Why? Because I have an exponent of 7 on my variable and an exponent of 2 on my other variable. I add those together and I get a degree of 9. So this is a 9th degree polynomial. Okay, what about this one? Well, if I look here, I have a variable with a negative exponent. So that would be the same as saying, like, that's 3 over x. And a polynomial cannot have variables in the denominator. So this is not a polynomial. All right, you guys try. What about this one? Okay, this one is a polynomial and its degree is 5. Both of my terms here have a degree of 5, so we just say the polynomial has a degree of 5. What about this one? This is not a polynomial because I have a variable under a square root. And this one? This is a polynomial and its degree is 7. Be careful here. Remember that in this term, the exponent is 1, even though it's not written. So the degree of this term is 7, the degree of this term is 1, and the degree of this term is 3. I pick the highest degree term, and that's the degree of my polynomial. All right, we're going to talk about simplifying polynomial expressions now with other operations. This is super easy. This is just combining like terms. So here, 2a squared plus 5a minus 7, I'm subtracting a cubed minus 3a plus 2. So here what they did is they distributed this negative 1 that was in front of this polynomial. So it made it minus a cubed plus 3a minus 2. And then you just combine like terms. So 2a cubed minus a cubed is 1a cubed. 5a plus 3a is 8a. And negative 7 minus 2 is negative 9. So that would be my final answer. Okay, when you're adding, it's the same idea. They're showing you here that sometimes if you want to do polynomials, you can also add them vertically so that you can line up your like terms. It doesn't matter to me if you do it vertically or horizontally as long as you do it carefully. So here when I add, I have 4x squared plus negative 2x squared, which is 2x squared. Negative 9x plus negative 5x is negative 14x. And 3 plus negative 6 is negative 3. So that gives me my final polynomial. All right, we'll come back to that in a second. I want you guys to try this one. All right, the answer here is D, negative x squared plus x plus 2. Last but not least, we can also multiply polynomials with the distributive property. So here I have negative y times this whole polynomial. So all I'm going to do is distribute that negative y. I'm going to multiply it by each term. So I'll get negative 4y cubed minus 2y squared plus 3y, and that would be my final answer. You guys try this one. Okay, the answer here should have been C, negative 3x to the 4th plus 2x squared minus 5x. All right, lastly, we're going to multiply two polynomials together. Remember, this is just the distributive property over and over and over. So I have to distribute every term of my first polynomial to every term of my second one. So you can follow the colored arrows there. This is like foiling to the extreme a little bit. And this would be my final answer. Try this.